Hello and welcome to Intro to GIS Week 2. Today we're going to review a bit of the main concepts in Chapter 2, which is about tables, attributes, and queries. Okay, so to start, let's just take a quick look at where we've been, where we're at for this chapter, and where we're headed. So in Chapter 1, we basically learned about some of the possibilities in Pro, how it is laid out, some of the tools we use frequently, and a general orientation with how it works. In this chapter, Chapter 2, we start to look at some of the key components necessary to do something called spatial analysis. And in Chapter 8, which is what we're moving on to next, it sounds like we're skipping far ahead in the material, but in fact, I'm actually just going to the next chapter that actually moves on to do more complex spatial analysis. So I also wanted to just put in a caveat here about the sort of shorthand language I use. I call this Pro just to obviously talk about ArcPro, ArcGIS Pro software, but you could also say that when you use the term Pro, or you are talking about any kind of geographic information system. As I had mentioned in my previous lecture, there are other software systems out there, and they all generally do the same thing. They might do it slightly differently, but they all kind of do the same thing, which is spatial analysis. So when I say Pro, you can actually do this in a variety of different settings. So the idea of having a whole chapter dedicated to tables and queries might sound a little simplistic, but there's a reason why why this is the case. This is essentially, as we're going through this, developing the building blocks for understanding how everything works and functions in GIS when you're doing spatial analysis. So tables are important because they are the generic format that the data takes, the attribute data, when you're viewing it through Pro, or actually in any kind of GIS. And tables contain the non-geospatial characteristics of a vector, which is the point, line, or polygon. And the attributes are on this above-mentioned table. So this in turn gives us attribute tables, ta-da, which you'll be using a lot. Every layer that you work with has an attribute table, and anytime you want to run any kind of analysis on it, you will be using that attribute table. You'll be opening the attribute table, looking at what's on it, seeing where there might be errors. You can run lots of analysis just on the attribute table itself. So they're very important to just get familiar with and comfortable with looking at. So last for this chapter, but certainly not least, attribute tables are the basis for asking questions of the geospatial data. Hence, they are called queries. Queries are one way in which we use spatial analysis, something we'll get into a little more next week. So why is this all important? Because attribute tables and queries are the foundation for doing more complex spatial analysis, which is the whole part of reason for learning GIS. So I actually wanted to just go a little bit more into what I mean by spatial analysis. This is a term I've thrown about a lot, I feel like, without perhaps giving a little more context. So I pulled up this definition. I thought this sounded nice, although there's many ways one could frame it. So the spatial analysis concept, this says spatial analysis is the process by which we turn raw data into useful information. And according to this, it says it is the crux of a GIS because it includes all of the transformations, manipulations, and methods that can be applied to geographic data and to add value to them, to support decisions, and to reveal patterns and anomalies that are not immediately obvious. So chances are the definition to the right might still feel a bit vague and big, but as we progress through the chapters, it will start to come together more. So spatial analysis, or SA for short, is in essence one of the primary functions of a GIS, and the study of the various techniques, tools, and approaches to doing spatial analysis is what we will learn about in this class. And as a result, you are learning to become a spatial analyst or spatial data scientist. So spatial analysis is just a generic catch-all term for what you are doing in a GIS. Okay, so don't get too caught up in feeling like you have to understand exactly what that is. This is what it is. We are doing spatial analysis. So I want to just back up for a minute before we sort of continue on with the details of the chapter. Thoughts that occurred to me as I was doing the lab and reading through material. Perspectives on GIS. So this is a message I will reiterate throughout the semester, that learning how to work in Pro or any GIS is not just learning how something works. It is actually learning a whole new way of thinking about how to organize data, both geospatial and non-geospatial, how to analyze it, and how to conceive of and answer questions about the world. In short, learning a GIS is sharpening your skills as a researcher and critical thinker. So it's more than just sort of learning how Excel works. It's actually learning to kind of recast the way you think about and solve problems, especially if something has a geospatial element to it. So as in keeping that in mind, you really have to be patient with yourself. And remember that you are learning what works for you. Pro is a slightly more complicated on one hand, but not complicated on the other approach to doing GIS. And there are many ways to figure something out and how to do things. You have to just sort of go with the flow, learn what's being taught in the textbook, but figure out what works for you, because ultimately you're the one who has to, you're the analyst, right? You're the one who has to sort of figure out how the best way to solve the problem occurs to you and your personal sort of way you conceive of things. And also I wanted to add some perspective on this textbook. As I've mentioned before, this textbook is new, and I'm learning as I review the chapters how different it is to the other book. And one of the things that Shalito has changed in this textbook, and it's worth bringing up, is that he does cover the basic instructions to achieve learning outcomes, such as these basic things about what is going into a GIS. But he's also including a lot of lateral skills that can represent more complex functions, and that's what's sort of new, and that's actually one of the features of Pro. So while you're learning the basics, he throws in something a little extra on top of it that wouldn't have necessarily have been included before. But because of the way Pro works, because there is so much more capability, because of its sort of in-between status of being like a desktop software system and something that functions in the cloud, there's just a lot more you can do with it. So when you go through this chapter, and I'll highlight this at the very end of the slideshow, there's a couple of lateral skills I like to call that he brings up that are new to learning GIS, but are also very important. Okay, so the first basic thing we get into in this chapter is, or that I want to review with you, is just accessing the attribute table. As I said, it's an important thing that you'll be doing all the time, and you can do it two ways. You can do it via the right click, and I show a little screenshot here of what that menu looks like when you do the right click, or you can access it through the toolbars and tabs at the top, so you can sort of see the way down to where you find the attribute table tab highlighted in blue. I'm a student of the right click. I just right click everything, so that to me makes more sense. But the toolbar thing is what is kind of the new part of Pro, and it just opens up a different way of thinking about and approaching how you do your GIS stuff. So just a little word to the wise on the right click. The right click will open up a lot of doors for you if you ever get lost and you're not quite sure where to go or where to find something. You can always just try right clicking, because there will be menus that will open up that will possibly bring you to where you want to be. Also, if you ever find yourself having to work in ArcGIS Desktop, which will look a little different than Pro, the right click is going to save you a lot there as well. It actually is more fundamental there, because that is in many cases the only way you access a lot of the functionality. So just know the right click is your friend and will answer and or clarify a lot of questions for you when you're trying to do something. One other thing I wanted to add, and I add it, I guess, because there's so many things I contribute, I want to say, and I realize I want to say that it's in relation to doing desktop, which you guys don't do desktop, so it doesn't matter to you. But just so you know, when you open up, you can open up multiple attribute tables, and they'll always open up at the bottom of the screen, and they'll just sort of keep opening up to the right, like so there'll be tab after tab after tab. So if you ever open an attribute table, unless you've actually closed another one, it's still open and it will be down there. So your attribute tables are always visible down there unless you actually close them. Okay. So here I have a little illustration, this is in the book as well, on data types. Read this over, think about it a little bit. It can be a little kind of confusing and at first when you're working with these different kinds of data, nominal, ordinal, interval, and ratio. But the reason why it's good to know, or just to know it exists at this point, is because the data that goes into our attribute tables is of one of these kinds. And depending on the kind of data it is, there are certain things you can and cannot do with it. So nominal data is just data that is not, that tells you something, but it's not a number that you can actually calculate. Whereas on the other end of the spectrum, ratio data are numbers that have absolute zero, and you can run lots of statistical analysis on it. So in the middle are ordinal and interval data, and where order is important and ordinal, but there's not a known quantity between the orders, and interval data. where there is a scale and exact difference between the values. Interval data is also easily able to be easily analyzed, but ratio data is the best. So just be aware that that exists, and as we go through more analysis in GIS, we'll be paying more attention to this kind of data. So one of the other key things we do in this chapter is joining tables. Joins are based on a key where the data type is the same. I'm sure this will kind of be very intuitive and make sense to you when you go through it. You kind of, if you're going to join up tables, you have to have a similar, it's like a common denominator, so to speak, that brings the two tables together. And when tables come together, they literally just append one to the other. So that includes everything that's on one table and adds it to the other table. So in order to do this, you actually have to execute a geoprocessing tool. We've already used geoprocessing tools in the first chapter, but you use it for this one as well. And I'm going to talk a little bit more about geoprocessing tools in a moment. So let's just move forward and talk about why would you want to join tables? Well, as you'll see in this chapter, if there's data contained on one layer that's not in another, but you're not ready to run a spatial analysis geoprocessing tool, you want to create a new table, a new layer. You just want to join the data together so that it actually becomes visible on one layer. So this is useful in a lot of different circumstances, especially when you're dealing with kind of finding your own data and trying to create original work. You'll have to oftentimes join tables. So I wanted to talk a little bit more about what geoprocessing is in general. You see it up here, this geoprocessing tool, and the tool in this case is the add join. And when you do the lab, this will obviously, you'll do this and it'll make a little more sense. But I wanted to just speak briefly about what geoprocessing is in general. I felt it necessary to do this because when I started officially studying GIS, I was a little, not so much confused by what geoprocessing is, but I felt like I couldn't quite pin down why it was important or what was going on with it, or when was I doing it, when was I not? Well, geoprocessing is really just this generic idea of how the analysis works or how the analysis happens. So if we look at one definition here from Shalito, it says the process of taking an action on a data set that results in a new data set being created. And my kind of shorthand for it, my definition is any tool or tools used to analyze the data contained within one or more layers that results in the creation of a new layer. So again, I'm just going to read this because I wrote this out and I think it makes sense, I hope. Geoprocessing, shortened to GP, is a very generic term for essentially everything we ask the software to analyze. You know you are doing geoprocessing when you open the tools and use one, but really everything we ask the computer or the software to do and to change on our map, even if it isn't through a tool, is still geoprocessing. I bring this up because, again, when I was learning GIS, I felt the term was somehow something more specific than it is. In essence, it is the how behind the spatial analysis we are conducting. So spatial analysis involves using us as analysts to ask questions of geospatial data. The geoprocessing is how those questions are answered. So it happens in a variety of ways. It primarily uses tools. We'll use those a lot, but again, just think of it as it's the how behind analysis. So now we're looking at performing queries. These are kind of fun. They're kind of like logic questions in some ways. And in this case, we're starting by select by attributes. There are many other ways to do queries, but we're starting off with the basics, of course. And it is a form of geoprocessing. It's useful when you have attribute tables that contain a lot of descriptive or nominal data, or any kind of data about a point, line, or polygon, i.e. a location, and to want to explore and compare the information. Queries are based on something called SQL, or structured query language, which is very common for analyzing many kinds of databases out there. And there's a good description of it on page 48. And in this exercise, you're creating a selection based on attributes, as in the information in the attribute table, which contrasts with selection based on location, which we'll cover in a later chapter. But it's worth noting that there are other ways to perform queries. Queries can be simple or compound, so you can have just one phrase that you're looking at, or you can have multiple, which you will do in this lab. So queries are like you are literally asking questions of the data. You're querying it and using if and clauses with greater than or equal to or less than kinds of formulations. And just to note that when you're opening this geoprocessing tool where you select layers by attribute, it's pulling all of the information from the attribute table that you ask it to. So you can see here in this, you're asking it to pull that information from the Census Counties, Ohio attribute table, which is when you move over to the next screen where you input what actually you want it to look at. It's pulling all the information from those fields. Okay, so what happens when you do this geoprocessing of querying data? Oftentimes, it results in the creation of a brand new layer that has the information that you wanted to pull out of the layer and puts it on a new one. This is the fun part. This is where you actually start to kind of customize and become the analyst, because you get to see exactly the results of the question you asked of the data. And these layers they get automatically put onto your table of contents. Sometimes you can get rid of your old layers if it produces a result that you want. Other times you want to create multiple versions of a geoprocessing tool or a query and create multiple layers that you can compare. There's a lot of stuff you can do with it, but this is where it starts to get fun and where you can start to compare different results. Okay, and last but not least, like I had said at the beginning of this, Shalito adds these sort of lateral skills. And in this case, the bonus in this chapter are configuring pop-ups and adding attachments. So these are, for us contemporary users, these are very intuitive features to have on maps, especially since we're very typically using maps on the web. So the idea of being able to click on an icon and a box pops up and it has more information about that makes sense. That's the way it works. But when we were working in desktop before, that wasn't the case. You actually you could create it, but it wasn't as interactive. Whereas on web maps, again, or ArcGIS Online, which is still there, but that was the way you could do those kind of interactive maps. So now with ArcPro, like it's bringing together those two kinds of variations of GIS. And so there's these elements of ArcGIS Online that are coming in to interact with the more heavy-hitting software side of ArcGIS Desktop. So we can now configure pop-ups in a really cool, intuitive way, and also add attachments and pictures to make it a little more user-friendly and more easily publishable to an online format. So again, useful to know, and we'll be using those again throughout the semester. So that is all for now. I hope this was useful, and I will talk to you guys later.